Okay, good morning, day, evening, everyone. My standard first question is, can you hear us and see us? You're supposed to see five fine-looking gentlemen on screen. So if someone can just, um, can you hear us? I see a lot of good mornings. Good morning.
Okay, yes.
Actually, yes. Okay. Okay. So welcome everyone to another Stark at Home episode featuring, I think it's going to be like the record in terms of attendance. Right now we have over 400 listening in, and the number is going up. I can speculate as to due to whom we have this honor. So we're going to have Vitalik Buterin, all of you know him, who's going to do a very deep and hard grilling of three co-creators of Cairo 1.0 and Sierra. We have Leo Goldberg, head of the StarkNet engineering. We have Shachar Papini, Cairo and Sierra co-creator and senior engineer. Ziv, head of the compiler team. I'm going to give a very brief introduction and then just hand it over to Vitalik to do the hard questioning. So this is a series of crowdcast or webinars in which we talk informally about sometimes deep and complicated stuff related to the technology stack of Starks and StarkNet, in this case, Cairo. But we talk about it informally and just via free discussion. You're welcome to later on check out other episodes in the series, the stuff about math and other protocols. If you have a question, the chat is not a very good medium. In particular, I mean, let's say that collectively the world has said good morning and we also say good morning. So let's stop with that. If you have a question, please use the ask a question. We'll pause from time to time and answer those questions. Okay, so what is this about? So I guess that you all know and love Ethereum and its machine in the middle of it, which is the Ethereum virtual machine, and the popular programming languages in which developers build on it, like Solidity. There are others, Yule and Viper. Now, StarkNet is a layer 2 validity rollup, also known as a ZK rollup, that relies on Ethereum for consensus and security. And surprisingly, it has a different programming language, a new one, and a new virtual machine called the Cairo virtual machine. And now it also has a new language called Cairo 1. And it has also a new intermediate representation, which is Sierra. So the big question is like, why invent something new, and why not just go with something that is already existing there? The obvious first choice would have been the EVM and Solidity and things like that, but you could also think about, I don't know, Rust or Python or JVM or anything. So that's like the question that's hovering about, and I hope that a trio here has some good answers, because I don't think Vitalik's going to give them an easy time. So I'll just say that the core technology that at the end all of these runs of the virtual machine are converted to is a validity proof system called Starks, that all of the systems over that we are involved in has been using, in particular StarkNet, and it is deeply connected to that. So those who want to learn more about that piece of math, there are other episodes and other resources. But the focus of this is about this this new language. And I'll hand it over now to Vitalik, and I'll just listen. And from time to time, just pause to help ask questions. So Vitalik, please.
Yeah. Okay. So I'm asking the questions, right?
Yes.
Yes. Okay. I mean, maybe
the discussion.
Sure. I mean, yeah. Well, maybe just to start off, maybe can some of you guys like start with the basics and explain like what is the property that Cairo has that, like, for example, the EVM or WebAssembly or like any of the existing VMs don't have.
Yeah, I can explain. I'm assuming you're talking about the Cairo VM.
Yes, sorry. We should use good terminology. A chasm.
Yeah, chasm, Cairo assembly. Yeah, so properties that Cairo assembly has, because it is written to fit very well to ZK proofs and not just running on computers. First of all, the memory model is a write once memory model, an immutable memory model, so you can just have pointers to addresses and change them as you want. Also, the basic type inside the basic word is not like some bits, like it's not 64, it's not 256, it's just a field element. So operations with field elements are cheaper, and want to be able to express that. Anything I missed?
No, the main thing is efficiency. So while EVM may fit EVM and also x86 may fit to run in an x86 environment, when we want to generate proofs, we need to translate everything into field elements. So there is if you start with something that's not built for proofs, you will need to pay the extra for converting from U to 56-bit integers to field elements. And the Cairo virtual machine, which was designed as something that you should prove, was built to exactly for this reason. And this is why we have all the things that Shachar mentioned.
Mm-hmm. Right. So, as I think I understand the like anything that anything arithmetic that gets verified by a Stark or any other kind of proof at the base is made up of like math that's done with field elements, right? And so for that reason, having a VM that just directly has field elements is going to be much faster than emulating some other object over field elements.
Exactly.
Do you guys happen to know the number of like how many field element operations it takes to emulate, like let's say UN64 or 32 to 56, just anything that kind of more regular developers are used to?
So the question was how many field elements I need in order to emulate, for example, let's say a 64-bit operation.
Sure. Mm-hmm.
So I think it's in the around 10 tens.
Tens. Mm.
Mm-hmm. Tens probably, yes.
Tens. Okay, so still pretty significant. That's well, I mean, tens is the difference between it taking 200 milliseconds to verify a block and it taking 6 seconds. So it's a big deal. Okay, so I guess that okay. So the the Chasm virtual machine is optimized to kind of take a very like small amount of proving to kind of prove each step, as I understand, right? So like about how many? Do you know right now like about how many steps that is, and like maybe compare that to like some other kind of computation, like some other virtual machine or some other operation? Like just give an idea of like the difference between proving Cairo and proving anything else.
Today, proving a single step of the Cairo machine is about we measure it in cells, so it's about 50 trace cells, 50 variables, and I can try to compare it to other mods. For example, if you went with a read-only, read-write memory model, it would be, I think, at least twice.
I think it's in the 200 area. So it's 4x to move. And this is if you take Cairo and just add to it read-write a memory model, then it's like, I think it's 4x.
Right. Do you guys happen to remember like the stats for just any other virtual machine that's not Cairo? Like one step of that. Like what would you estimate?
You're talking about a virtual machine that is mapped to
right. Mhm.
I'm not sure that we have one, right?
Yeah.
I remember TinyRAM, which was a
Yeah,
very
TinyRAM was in the thousands, I think.
I think it was like, well, it was a bit okay. It was like I think around 100 or 130 cells per step, but the constraints were of degree 8, and memory was dealt. This was before player graph, so memory was like some huge additional swath, and
Right.
it wasn't a very powerful machine.
Okay, so it was like basically before Cairo, it's proving these things was tens to hundreds of times slower, and they were less powerful, right? Okay,
Yes.
that's I think that's
Also before Cairo, I think these things didn't exist, so this is also something to take into account.
right. That's a good point. Okay, so I think that's like a good intro for people for why something like Cairo needs to exist, right? It's very big efficiency gains if you specialize. Maybe can we kind of zoom out a bit and talk? Why Chasm needs to exist. I need to get good at the language myself too. Can you kind of talk about not just Chasm but sort of the full stack of languages that you're creating? And what the role of each of those languages is.
Oh, you want to take it?
Sure. Sure. So we are writing Cairo 1, which should be the high-level language that enables us to write codes easily and securely. Sierra, which is the intermediate representation that would be accepted by StarkNet, and this is at the security level. We'll discuss later. And Chasm itself, which is the existing code for the virtual machine, and our stack basically knows how to translate code into from the higher levels to the lower levels. That's the
thing. So mainly we had in the past we have the Cairo virtual machine which we described. This is basically writing assembly code. No one wants to do it for actual contracts. So we had in the past Cairo 0, which was a language that compiled to this Cairo assembly. And what we're replacing Cairo 0 with is actually two representations. Sierra is the intermediate representation which will compile down to Cairo assembly, and Sierra is still very assembly-like. Again, no one wants to use this directly to write contracts, so we have a higher level language that compiles to Sierra, which compiles to Chasm.
Right. Okay. Also, one thing that I understand is that with smart contracts published to the StarkNet system, it will be mandatory to submit them in Sierra, right? So you will not be able to submit Chasm code directly.
Indeed.
Right.
Okay. Can you maybe speak to some of the reasons why it has to be that way?
Yes. The main issue with submitting Chasm directly is about things that we can't prove. I mean, one of the strengths of Cairo is that you can't prove invalid things, but it's also its weakness. Because if a user sends a transaction and it's reverted in some way, it doesn't have enough balance, it does some invalid operation, there is no way to make a proof out of this computation to prove, hey, this user submitted a reverted transaction and you need to collect his money. So this is an opening for denial of service. So here Sierra comes to rescue us. Every program that is written in Sierra is by construction, it cannot fail. We can always prove it. And now when a user doesn't have enough money to do anything, instead of doing something that can be proved, we are proving that you can do it. We're like returning false in a way, returning, hey, this can't be done. So Sierra adds this layer of security that anything is written in Sierra can be proven, and that is what the guarantee that we get if we had a Sierra program and then compile it to Chasm. we know this chasm is safe to execute. It can always be improved.
Yeah, as an analogy, sending Cairo assembly opcodes to StarkNet is similar to sending x86 opcodes to Ethereum, which is something that we don't want to run any general code written by users. So we have in Ethereum we have the EVM. Which restricts what a user can do. And similarly, we have Sierra in StarkNet.
Right. Okay, so if you would run x86 on if we had an EVM where you just submit x86, right, then the risks that what would the risk be, right? Like, what are examples of bad things that could happen?
So, if are you asking about x86 really,
let's stay within the analogy. Like, let's say
So x86, in x86 the risks for sending x86 are much higher actually than running the Chasm. In x86, basically the user can do whatever they want on the host. The host in this case are going to be the validator, the sequencers, maybe the full nodes, and so on. So this is not something that we want. If we're talking about Chasm, then it's not that bad, because Chasm itself is limited. You can't open files in Chasm just because you don't have any instructions that does that. The main risk in running Chasm without any safety mechanism is denial of service. So it's a transaction, for example, it runs a lot of time and then fails after wasting a lot of computation power. And if the transaction failed in a way that you cannot prove that it failed, then you cannot charge fee for this failing transaction, which is the way Ethereum solves it. So if in Ethereum, if you have a failing transaction, you still pay fee for it, which is good. If you cannot prove that a transaction failed, you cannot take fee, and then you are open to a denial of service attack. And this is what Sierra helps us avoid.
Right. So, yep. Basically, that's exactly the reason to use the EVM as opposed to using a sandboxed VM that is kind of not explicitly designed for that purpose. That makes perfect sense. So can we maybe get into what are some of the mechanisms that Sierra uses to kind of deal with computation that tries to do an infinite loop, for example? Like if I if I try to stick an executor of the Collatz conjecture or some weird thing that lasts a really long time, and we have no idea how to compute how long it takes. Like, how would an execution of Sierra handle that?
Ori, do you want to take this?
Sure. So the basic premise that we have there is allowing a rather small surface for what we actually allow to do, similarly to what EVM does in a way. So there's a limited set of instructions. Our instructions are more numerous, and they basically take variables and return new variables while keeping some sort of type safety. So as we said, Chasm itself only addresses felts generally, but here we also have various sort of numbers. We have U186, 128, I'm sorry, U64, and so on. And we simulate it under the hood using felts, but the logic itself is type safe over more high-level types. And using this, for example, we can avoid division by zero. If we only allow division by a type that is, I check this is not zero, I got that variable that is already checked, so I know I won't be able to do something that is bad.
I want to say that type system and linear type systems in particular are apparently very strong, and you can enforce very strong invariants with them that help us make sure that nothing bad happens. Uh, Regarding specifically infinite loops and things like that, basically we want to count gas. I mean, similarly to EVM, like when a node simulates EVM, it counts gas, makes sure it don't go over the limit, and if it does, it reverts your transaction. Basically, we want to do the same thing, but instead of dynamically or just at every instruction, checking, do I have enough? Let's try another instruction. What the approach we take is a bit different. When we compile from Sierra to Kazem, we in the compilation itself add checks for the gas. So we basically make sure the program can count its own gas in a way. The compilation process itself gets the instructions from Sierra, and with the type system makes sure that each function counts its own gas correctly and does the checks that if it doesn't have enough gas, it returns. Basically, you can do that. I think it's similar to how optimized EVM implementations do gas counting. Am I right?
Yeah, okay. So maybe like, would it be reasonable to summarize like quickly by saying what happens is Sierra code gets translated into Chasm code, and when that process happens inside of the StarkNet consensus, right? Because StarkNet consensus is getting Sierra code, and as part of that process, the compilation is inserting instructions that basically say, over here take away 5 gas, over here take away 30 gas, and if the gas is less than 0, then like exit and throw an error.
Yes.
Okay. Right. Except maybe the difference with EVM implementations is that in an optimized EVM implementation, like that's done by the interpreter, but here it's like those instructions are actually just being put into the code.
Yeah, they're added to the compiled Kazem, and then when you actually run the Kazem code, this is what happens. It counts for itself the gas, and the reason that we were okay with trusting the Kazem code to actually count correctly is that we didn't get Kazem code from the user. We got the Sierra code and compiled it ourselves. Ourselves here is the consensus mechanism.
Yeah, I just want to say maybe a little detail that it's the compilation from Sierra to Kazem doesn't insert new instructions that count gas. These instructions come in the Sierra representation, and all the compilation does is checking that we have enough checks everywhere and with the right amounts, so that to make sure the program is correct.
Oh, I see. So the Sierra code that I put on chain would have to already contain gas counting, and the compiler checks for that already existing.
Yeah, gas handling I would call more than counting, just because.
Sure. Can I ask what motivated the choice to do that instead of adding gas counting or gas handling in the compilation process?
Yes, instead of adding? One of the main considerations we had into designing this is to make sure the compiler from Sierra to Kazem is as lean and simple as possible. This is because, first of all, it's part of the consensus, and second, later in the roadmap, we want to have this compilation process as part of the proof, and since it's part of the proof, people want it to be as lean as possible, so the proof won't be too large, and also maybe easily auditable, so it should be simple. So this led to simple logic, just making sure that it.
Actually, I think Terence's question is interesting from the chat. What happens if the gas cost of an operation changes because you change the protocol at some point?
That's a good question.
That's a great.
We also wants to say something.
Okay, so this is a great question. We count different types of things. So I'll try to describe what happens in all of them. One thing that we count is the number of steps. The number of steps, we do not expect the number of steps to change when you change anything. So given a specific compilation in a specific version, the result requires a specific number of steps. So this, maybe I'll describe later why this is not entirely true, but let's say that we don't care about allowing us to change the number of steps. The second thing that we have are built-ins. Built-ins are part of the Cairo VM, which allows you to do certain operations like hash functions. And this is a place that may change over time. We may decide that we want to change and increase the price or decrease the price of a certain built-in. And this is why we don't hard code the prices of the built-ins in the compiled CASM, but instead we have whenever you want to use a built-in, basically you go to the StarkNet OS, asks for the price of this built-in, and this is what you reduce from the total gas counter. This and in the StarkNet OS, you can expect the hard-coded prices, but those may change. Those may change according to governance decisions, for example. The third thing is it's similar to built-ins. It's system calls. So for example, whenever you want to change something in your storage or call another contract, this is called system calls, and this is the gas handling is done entirely by the OS, so we don't have a problem there as well. The only thing that I didn't talk about is what happens if we have, for example, if we have a bug and decide that we didn't compute the number of steps for a specific lib fun correctly, and we want to change it. And in this case, when we're talking on the number of steps, we don't have a mechanism to do it. So the number of steps, the counting of the number of steps is going to be hard-coded into the compiled CASM. And what we can do in this case, and this is I hope that we won't get to this case, but if we get to this case and it's important enough, what we can do is to actually recompile the contracts. So we have the Sierra code, we can recompile them after fixing the bug. You will get a different CASM with the correct value.
Yeah, I want to mention some subtlety here. I think, in my eyes, part of the semantics of StarkNet, the protocol of StarkNet, is not necessarily aware of CASM at all. It operates in the Sierra level. Sierra is like the instructions for StarkNet, and the state and everything can be deduced just from Sierra itself with its own semantics. So compilation to CASM is sort of an implementation for a proof system.
So if I were to run a StarkNet full node today, would I be storing people's Sierra? Would I be like the smart contracts? Would I be storing their CASM? Would I be storing both?
I mean, if you don't intend to submit proofs, you don't need the CASM. You just need Sierra and maybe compile it to x86. Am I right?
Okay.
Yes. So you need the Sierra, and you can use the Sierra to either, for example, compile it to CASM and run the CASM. You can, in the future, you will be able to compile Sierra directly to x86 and get a very fast execution.
So you do it locally. Like, what's the thing that gets hashed into the state root? Like, I'm assuming you have Sierra. Okay.
Sierra and the compiled CASM.
And the compiled CASM as well. Both. Okay.
Both. Yeah. They both appear in the trees that we keep. Yes.
I mean, I just want to say that right now both are, but this is kind of a necessity right now because we also support Cairo 0. I'm not sure it will be like this in the future.
So this is just done for efficiency, so that you won't need to recompile every time you want to invoke. So the StarkNet OS needs to run the Chasm. This is the only place that we actually need to have Chasm.
Okay.
And there are two options: either start from the Sierra representation and compile, or store the Chasm in an accessible place.
Got it. Okay. I feel like we've gone a bit, like we spent enough time in this rabbit hole. One thing I wanted to ask more about is the linear type system, right? Because the EVM has gas, and I think a lot of the people who are listening, who at least of those who can follow the technology at all, they know what gas is, kind of, and how it works. But linear type systems are not something that's in the EVM, and linear type systems are possibly not something that even most Ethereum people have heard of. So can you maybe explain what is a linear type system, and what's an example of a thing that the linear type system in Sierra protects against?
I just suggest that after this micro topic, we take a few questions, okay?
Sure.
Yeah, go ahead.
Yeah, I mean, one simple example that Uri mentioned before is just dividing by zero. Yeah,
Right.
What happens when you divide two numbers? One option is not do anything fancy, and if it's zero, maybe revert the transaction.
Right.
Something else you can do is be a little more sophisticated and allow only division by things that are non-zero. How can you represent that? You can represent it by having some kind of type that no one can create other than maybe this specific function.
Right. But okay, so in linear type system, what does the word linear mean?
Yeah. Okay. Linear comes from the fact that you can have types that instances that they only have exactly one. They can't be duplicated. They can't be just dropped. You can always have one instance of it.
So it starts. It may travel to some places, and then it ends. So it cannot split. So this is the linearity for me.
The variable is created once and used once.
Exactly once. So you can't. Linear type system means that the types by default you can't use them more than once. They cannot disappear. You need to destruct them explicitly.
Got it. Okay. What's an example? Yeah, what's an example of something that linear types make safer or are useful for?
Yeah. First of all, it's a kind of a necessity for Chasm itself, because we have these constructs that but have dangers in them. For example, an array. In Cairo assembly, you can have some kind of array where you guess an address and you just write and write and write and write. And remember that the memory is write once. So if you have by accident two instances of the same array and you try to write to both instances, you may end up writing to the same address different values, and that's dangerous. So arrays are not duplicatable, and you can only have one instance of the array you just created. You can't duplicate it. There's one.
I see. So basically the idea is that because Chasm has this property that Chasm variables are write once, so therefore the language on top of it has to have a write once property too. Okay.
Exactly. The language doesn't have to be write once. So the high-level language doesn't look like a write once language.
Right.
But it has to be safe enough to make sure that the Chasm that we get will not be able by any, no matter what you do with Sierra, you must verify that you don't get two values written into the same place.
I see it. So maybe would it be fair to say that there are ways to implement regular write many times variables on top of write once variables, but the point of Sierra is not to add expressivity. The point of Sierra is to like add safety. And so Sierra itself, you're just keeping the same the same stuff that has to be in Chasm, and you're just trying to be parallel with it.
Yeah, I think the idea is to make so you can still write very efficient Cairo, but in a safe manner. So we want to catch as much use cases of Chasm, but still safe.
Got it. Okay. So I think my own next big question would be like, let's get to the kind of the third layer of the stack and try to understand Cairo 1.0. But maybe before that, some questions from the audience.
Yeah. So I'll be reading. So we'll go down some of the questions. I don't know if anyone wants to answer this because I don't know exactly what it means. It says, "What about extra security layers?" Does anyone understand the question and want to answer it? We'll take that as a no. I don't know what I asked there in a comment, so it's from Roberts. I don't know what do you mean by extra, like fine. Okay. How to evaluate the impact of StarkNet on fully on-chain games? Anyone want to answer that? I can give my answer. It remains to be seen. Like there are a few gaming companies that are building and deploying, and I don't know. Like Cairo offers the security of Ethereum and more computability at a lower cost. So you could use that for games, and maybe something interesting will come. Like, you could put more of the logic of the game on chain and be sort of have the integrity of the blockchain there. But what will folks do with it? I don't know. I mean, that's my answer to that. But who wants to also take a swab at it?
I mean, I know there are a few guys developing frameworks on StarkNet, like the Dojo framework that is doing work to allow a lot of games on top of StarkNet, which I think is very cool, to make it very accessible.
Okay, next question. Is there a tool to transpile existing Cairo 0.1 code to Cairo 1.0 code?
Yeah, this is a good question. So currently, we don't have such a tool. So we did change some. If you follow the versions of Cairo 0, the one of the last versions changed the syntax to be more Rust-like. So this was in preparation to Cairo 1 syntax, but we don't have a tool that takes Cairo 0 code to Cairo 1. Doing it properly is probably not possible because in Cairo 1 things are much more explicit. For example, the types in Cairo 0, most of the types, if you wanted the U64 type, you would use felt, and if you wanted U128, you would use felt, and if you wanted the contract address, you would use felt, and so on. And in Cairo 1, you have type for every one of those. So a tool cannot, or not, at least not in an easy way, do this transpilation. It's not transpilation. It's something much more interesting and much more details in the output. Maybe AI.
Yeah. Perhaps we can do it in a very, very inefficient way, but I'm not sure it's worth it.
I actually thought of a very efficient way to do it. Hear me out. So you take it's Cairo 0.1. So let's leave the point where it is. But then look at this. You do like this.
Write it 10 times and you get Cairo 1. Yeah.
Oh yeah, that as well. But I thought of something. You do this thing and
Yeah. So the answer is currently we don't have a tool. If we will have a tool, it will help you do the it's not transpilation again. It's adding details. So transpilation is not the word. The conversion, the migration. So it will help you do the migration. It will probably not be something that a one-click thing.
Okay, another question. Possible to make Cairo interoperable? All L1 should use it. I mean, I support that. I don't know,
to kind of expand on Abdel's answer, this might even be something I can answer a bit. Basically, so for Ethereum, right? So I wrote a post where I kind of touched on this topic and some other topics last week, but basically, eventually the Ethereum layer 1 will also be verified with snarks or starks or zero knowledge proofs of some kind. And when that happens, first of all, on the Ethereum side, the gas prices will probably have to be changed to be based on the cost of proving inside a snark instead of the cost of running it locally, if proving it inside of a snark is like the main thing that people are doing, right? But then the other thing is that creates room for potentially Ethereum to add new operations that are optimized for a kind of running inside of a snark, and for those to have like very low gas costs that are kind of proportionate to those much quicker costs, right? So I think if people want it, like I think there is potentially a roadmap for like putting big parts of something like Cairo into the EVM in some way that it becomes accessible. I mean, the EVM has to, I think, continue being available in some form. I mean, maybe there's like a 20-year future where, Cairo becomes the only VM and legacy stuff gets pushed through Kakarot. But, these are like long-term Ethereum futures. And I think it's not decided. And, you guys can, I think, can and should be part of deciding it.
Okay, I used to work in C language programming. How to better get started with Cairo programming? I'll just give one answer. I'm actually going through Starklings, and I put it in the call to action. It's a very nice tool for getting onboarded. And if you look at that question, there's a bunch of resources. I'll copy them also into the message. But please, others, if you want to chime in.
I want to say that we are currently in the process of extending the documentation on Cairo 1 quite extensively. So I assume that in the next few days you should have something that is a lot more accessible, and you can just start writing Cairo 1, hopefully. Also, I hope that very soon anyone could just use Scarb. Scarb is like the manager for... it's like Cargo for Rust, if you are familiar. Basically, it's a
package manager.
Yeah, it's not just a package manager. It's a lot of manager. Yeah, you should be able to download Scarb, and you get the right version and maybe the language server, and just start hacking away. But that is soon, hopefully.
So let's take one more question from further down, and then I'll hand it over again. So how is the Sierra to Kazem compiler designed for evolution? Sequencer node must be recompiled and restarted, or is there some way to update it on-chain?
So currently, if I understood the question correctly, the compiler version, the compiler is part of the sequencer. So it means that a new version of the Sierra to Kazem compiler basically requires an upgrade to the sequencer, similar to forks in Ethereum. By the way, this is not the case for compilation of Cairo 1 to Sierra, so we can continue to improve the higher level language without touching the sequencer. And also, it's possible that someone will invent other languages and compile them to Sierra, and those can also be used. Anything that was compiled to Sierra can be used on StarkNet.
Okay, so I'll hand it back to Vitalik. You wanted to ask now about Cairo, I think. 1.0.
Yeah, the third layer of the stack. So what is Cairo 1.0? What features does it have? Why would I want to use it? Go.
Yeah. What was the question? I was just answering one in the...
The question is like, explain Cairo 1.0.
Okay, Cairo 1.0. Well, it's it's very different from Cairo 0. I think if you are familiar with Rust, then it takes a lot of inspiration from Rust, both in explicitness and trying to be at least near zero cost for things that you do. We don't have inheritance. We have composition. We don't have a polymorphism by inheritance of virtual tables. Everything we have traits and the implementation. Traits are like interfaces, and we have generics, which is a very powerful feature, and everything is using generics. And we have a linear type system, which is kind of nice when you want to do all kinds of things. This is a top view of Cairo 1, I'd say. Yeah, this is Cairo 1. Why is it good? It's good. You can write efficient code in Cairo 1 and make it very efficient in Chasm, and it should be kind of ergonomic and a lot easier to write in Cairo 0, definitely. In Cairo 0, it was very assembly-like. Here it's a high-level language. You can't really do a lot of mistakes that you could do in Cairo 0. The compiler protects you. You have a language server, which gives you a lot of nice information. Anyone wants to add things?
I wanted to say that Cairo 1 was designed as from the beginning as a high-level language, unlike Cairo 0, and we try to learn from all the reviews that we got regarding Cairo 0 and what were the difficult things. So if someone is familiar with Cairo 0, we had things like revoked references. This was something that really annoyed developers. So we made sure just from the beginning that things like this will not be in Cairo 1. This is in the comparison between Cairo 1 and Cairo 0. And as Shachar mentioned, a lot of things were taken from Rust, including a strong type system, traits, impulse, and other nice features.
Okay. How difficult do you think it would be for a Solidity developer to start coding in Cairo 1?
Does he know Rust?
I think I'm not certain. I'm not sure. This is the question. I think that it's as moving to other different languages. So when a developer knows any language, basically, or at least after knowing two languages, the third one is relatively easy to learn. And I think this applies. So maybe it didn't fully apply with Cairo 0 with the fact that you had to know what field element is and so on, but I think it applies to Cairo 1. It's another language, and if you know Rust, it will really look similar.
I see. Okay. Okay. Trying to think through what are some of the some more examples of kind of high level constructs that Cairo 1 has that make it easier for developers that Sierra does not have by itself?
Sierra is a fully linear type, and every variable is actually used once. So
I want to promote loops. Cairo 1 has loops, where Cairo 0 didn't have and the Sierra doesn't have. You can have loops. Yeah, sounds trivial, but it's not. Some other things you have is like sort of simulating mutable variables. You can write variables, local variables, and denote them as mute, and do some assignment. Logic looks like it was mutable, but under the hood, Sierra doesn't have mutable variables, so it does kind of magic to make it immutable.
It's basically just adding new variables instead, and making sure that to handle correctly merges in branches. And I wanted to add another thing. So basically, Cairo 1 hides a lot of details that you need to specify in Sierra. It gives you, for example, ref arguments that are arguments that can look like like a function changes them, and behind the scenes, such a ref argument compiles to an argument and a return value. But this is in Sierra, it's actually an argument and a return value. In Cairo 1, there is a nice keyword for it. I think
someone in the chat asked revoked references. So no, we don't have any revoked references anymore. That is one of the great properties of Cairo 1.
So while we're waiting for Vitalik to reconnect, maybe you can take some of the questions.
Yeah.
For instance, I really like this one by Robert Zambezat. What would you change in the Cairo design if you were to create it again? What is currently the biggest limitation of Cairo 1?
So, I mean, first of all, we did get the chance to write Cairo again, and that is Cairo 1.
Yeah, I think for Cairo 1 itself, it's really too early to answer. So Cairo 1 is a new project. This is, as Shahram said, this is learning from Cairo 0. We'll know in a year or so the answer to this question.
Okay, and I see that Vitalik is actually online, but I guess something in the technology kicked him out and he's trying to reconnect. So meanwhile, here's another question. Just 1 second. Why does Cairo only have Blake 2S in the standard library and not Blake 2B? Is there some kind of limitation or just not yet implemented?
2S, what?
Blake 2S, Blake 2B. Efficiency. So Blake 2S was, I think, was more. I checked it, so I think it was more efficient than Blake 2B to implement in Cairo. I mean, and this is why there is we can have it also Blake 2B. It's not something that it's feasible, just wasn't a priority.
Okay, let's take one more question and then
the question I want to answer. Someone asked, do you see Cairo 1 being used for other applications, not just crypto? Well, definitely. I think this is one of my largest passions. I want Cairo 1 to be everywhere. Everywhere you need the proof. There's a lot of use cases in the world that can benefit ZK proofs, and I think that Cairo 1 will make it very approachable for any of them. Maybe proving computations on the cloud, or proving that AI models did something correctly, things like that.
Yeah. So here's another nice question, and then I'll hand it back to Vitalik. Will there be the possibility to have private inputs to a Cairo program running on StarkNet, similar to Snarks with SIRCOM, to enable natively privacy applications? I'll answer that. I'll say yes. At some point, yes, for sure. And I also want to add that there's making things ZK is relatively easy. Like making the proof ZK is relatively easy. Designing for general purpose computation that is meaningful and composable, and you know what's going on, and still privacy is much harder. I mean, think about like a Uniswap, AMM. How do you a trade has happened. How do you exactly shield it, and who gets to see or compute the new ratio? Others, what do you?
Yeah, no, it actually is a hard problem, right? Because one of the limitations of Snarks as a technology is that the person who creates the proof needs to have the private information. And that property is kind of like it's limiting both, but then also like it means that if you're going to create complicated applications, you have to have programming languages that kind of natively design that around that property. And like I know the Aztec team is trying hard to do good work on this, but it's like, yeah, it's hard, and it's another frontier in computer science. So I wish them luck, and I wish anyone luck who's working on this. Maybe I'm actually forget. Did we have 1 hour or 1.5 hours?
Usually it's 1 hour, and we extend it a little bit. So
okay, yeah, I think that's fine.
Because I see like there's still more than 600 people listening in.
Yeah,
so
sure. I mean, I'm happy to expand extend for a bit. Yeah. Maybe just kind of one final nerd topic. So field sizes, right? So basically, this is this idea that like when we talk about a field element, right? Like it's a number inside a field, and a field has a modulus. So like for example, if the modulus is 7, then any element in the field is like a number from 0 to 6, right? So numbers less than 7. And there's like special rules for how to add and multiply and divide these numbers so that the result always stays less than 7. And the two like in general so far in the crypto space, stuff has been in fields that have a 256-bit size roughly, right? So like the modulus is somewhere between maybe 2 to the 252 and 2 to the 256. So you need 32 bytes to kind of contain every number, right? And Stark's open the possibility of going much lower than 256-bit. So I guess one question might be like, what is what field size is StarkNet using now? Are there plans to look at reducing field sizes? Like what might the benefits of reducing field sizes be, and what might some of the practical challenges be of field sizes potentially changing over time?
Okay, so I'll start and let Shachar complete me. So StarkNet is using at the moment a field size of 251 bits. This has, I think, two main reasons. One is historic reasons. This is where we started with StarkX, and people started using StarkNet, and now changing the field size is not something that's easy to do. Shahar will say a few more about how we can do that. And the second is cryptographic primitives. For example, signature verification in wallets. So if you start reducing the field below 256, then you need some other mechanisms for signature verification, which are different, requires wallet support and so on. So these are the two reasons that we are working with the 251 bit field. And I will also say, so you asked what are the pros and cons? Why not use other field sizes? So basically, as you go down, for example, to 64-bit field, multiplication on arithmetic operations in the field are cheaper. And if for example, if you want to do some computation and your numbers are less than 1 million, say, then having a field of 64-bit is more efficient than having a 256-bit field. It will just give you more performance. Going below 64-bit is not that efficient, just because the way CPUs work. So 64 is the size of the world in a modern CPU. Doing things in let's say 32-bit or 16-bit field is not that efficient. It's it's not more efficient than 64-bit, so why not go with 64? So 64 or slightly less seems to be like optimal in terms of general purpose computation. Shahar, want to
Yeah.
say more?
Yeah. First of all, I think that if we had a chance to do it all over again, maybe we'd start with small fields to add the efficiency. And it may be it's a little more harder right now, but we do think about it and have it in our minds. One of the ways we plan to do this move is through Sierra itself. Sierra is actually a very good opportunity for that, because we are going to change how all the contracts are stored on chain. The idea is that Sierra is an abstraction that isn't specific to field elements, to this specific element or another. So theoretically, we could later, when we want to move to small fields, we could just take the Sierra, which stays the same, and compile it to a different Cairo assembly, maybe Cairo 64 assembly, something like that. The semantics of Sierra are well defined, regardless of the field itself. Now, it does pose some inefficiencies if we want to take the big field element and kind of simulate it on small field elements, then it would be expensive. However, if most of the code that is written using the field elements, things like U64, U128, then this will be more efficient. That is why we encourage people writing on Cairo 1 today to use the types they need, like U size, U1, etc., and not necessarily go to field element unless they really need it.
Oh, I see. So Sierra basically has these like built-ins that are field size independent, and that'll make it easy to recompile them if the field size changes.
Yes.
Yeah. In Sierra, the type felt, which stands for field element, is a type just like the type U64 and U118.
Specifically, it's called felt 252.
Right.
I wonder if we did have, if there was a question, how would the things be redesigned? So if we could have a time machine going back even further, it would have been nice to start with a smaller field. And I just want to point out that there is a nice research question that from time to time we've been looking at, which is how to basically combine different moduli and different fields in an efficient way, or various efficient ways. And I think it's a nice research question that I'm optimistic some good answers can be found for.
Okay. I think that's all fair. Maybe how about we close this off with kind of some more sort of practical and zooming out, right? So we've talked about 3 languages today, right? We talked about Cairo assembly, which is this language that is optimized for one step being very cheap and very easy to prove inside of a Stark, and that's kind of the base language that gets proven. Then on top of that, you have Sierra, which adds safety on top of Chasm, and programs that people send on the net. Published to the network to get have to be written in Sierra, and the compilation happens in protocol. And then you have Cairo 1.0, which is a higher level language that adds expressivity and makes things easier for developers on top of Sierra, right? So level 1, Chasm is base, Sierra adds safety, and Cairo 1 adds expressivity, right? So when can when and how will this affect users of StarkNet? Like, when will I be able to write code in Cairo 1 and actually publish Sierra that gets included on chain?
Yeah. So that the short answer is no.
Okay.
So Cairo 1 is available for quite some time. We're still working on it. A lot of things need to be implemented, but like a basic smart contract can be written in Cairo 1. So this is Cairo 1 Sierra, and the ability to use Cairo 1 on StarkNet is something relatively new from the last few weeks, but this can be done now with some limitations. It cannot be at the moment cannot be used on mainnet. We want to make sure everything works well before we put it on mainnet. But this can be done. So you can actually write a Cairo 1 contract, send it to StarkNet. It will send the Sierra bytecode, and the sequencer will compile it down to Chasm.
Okay. So would it be accurate to say that, like, in this transition from Cairo 0.1 to Sierra and Cairo 1.0, Chasm has been unchanged?
Chasm can, yes.
Wait, Chasm has not been changed.
Yeah.
Right.
Okay.
No changes. It's the same. It's the same Chasm, just with the safety properties that you will always be able to run the Chasm that was compiled from Sierra.
Got it. That makes sense. What are some, like, are there future plans for this? Like, are there plans for Cairo 2.0? Are there plans for future improvements to Sierra that you already have in mind?
I mean, I think I have plans for upgrades to the Cairo assembly itself and the Cairo VM.
Okay.
There are improvements that can be done there. Very, very nice.
Hmm.
Sierra, we do plan to add libfuncs or extensions on top of Sierra all the time to add more functionality to it. And later, like you said, maybe compile it to small fields. On the plan is to have the Sierra to Chasm compiler later be written in Sierra itself, so it can be compiled inside the StarkNet OS. Yeah, these are the main things.
And a lot of improvements to the Cairo 1 language itself.
Yeah.
So both in the convenient perspective, like for example, Shahar mentioned loops. I don't think that we have loops, all the kinds of loops at the moment. Maybe we have one.
Just the loop.
The loop, yeah. So this is one thing that will, of course, be improved over time. And the second thing is efficiency in compiler optimization from Cairo 1 to Sierra. This thing will all. There are a lot of things that we want to do in this area as well.
Yeah, Abdel wants me to mention that want Cairo 1 to also be available not as a language for StarkNet, but as a language by itself. And when we do have this, we'll probably want to add some kind of unsafe Cairo, maybe to add some hints on top of it, and maybe we'll use this when we write the compiler that will be inside the OS. Yeah.
So maybe we'll take a few closing questions. We can't answer all of them. They're like 35.
Sure.
Some of them are really, really, really good. So why don't everyone, you can scan the questions. I can say a few nice ones. For instance, Eddie is asking, it seems that StarkNet transactions are slower than competitor ZK VMs. What kind of optimistic approaches can we take to show user faster feedback on transaction acceptance, rejection? And then guys, just go over the questions, find one or two you like and answer them.
And so I'll answer this. Some of the reason that StarkNet was relatively slow in the last few weeks or more is basically the demand. It's a question of demand versus supply. So currently we don't have any fee market like Ethereum has. So if there is more demand than what we can actually process. Then there is a backlog of transactions, and this is the main thing that slows things down. We plan to have two things to improve this. One is to continue and improve the performance of our sequencer, so that transactions will be processed faster and you will have more throughput. In order to do that, we are doing two things. So first, we are going to change the implementation. The current implementation is in Python. We're moving to a Rust implementation using Lambda classes, Cairo VM, and so this will give an improvement in performance. Something that will be later is as that we've also mentioned it today, is compilation from Sierra directly to x86. This can also give a huge improvement in performance. So this is one direction. The second one is adding fee market. This is necessary whatever throughput we can handle. The demand will always be more than that. So we can increase the throughput and the demand will increase. So we need some kind of fee market like Ethereum has. This is also something that we will add. And finally, and unrelated to backlog thing, we plan to move to smaller blocks. This is something that we'll do probably do soon.
Yeah, I just want to add to this maybe one of the maybe ideas we have for the future is typed StarkNet, which is adding the semantics of type safety, of linear types, not just in the context of a single contract, but between contracts in the state itself. Very similar to maybe the move language that used for things like SUI. This will enable us to maybe statically know that two transactions cannot touch the same resources and do some kind of parallelization. This is one of the ideas.
Okay. What other questions do people want to answer? Let's take like one or two more, and then I'll just mention that those who are intrigued and want to learn, there's a bunch of resources out there. The one I confess that when I have time, I'm doing it slowly by slowly and greatly enjoying it, is this thing called Starklinks. And I put in the call to action button you can press and get there. It's a very nice tutorial or interactive tutorial based on Rust links, which is also very nice. So any questions folks want to take?
If you have your favorite, ask your favorite question.
I want to answer a question that hasn't been asked yet. I just want to have it. I think Cairo 1 and Sierra were developed like in a very general sense. When I first considered a high-level language for StarkNet, we looked at a lot of existing languages, maybe like Rust or maybe Haskell or maybe other stuff. It's hard to take these languages and just modify them to have maybe immutable memory, or just change the basic data types because it's so part of the compilers. I think that Cairo 1 and Sierra are a lot more extensible. I can imagine a future where you can just take this toolchain we built and change the core lib, change the lib functions of Sierra, and just have the same language but completely different basic data types and structures and maybe different blockchain and everything. So it's kind of generic. Yeah. Thank you for asking this question.
Okay, so I suggest this was a tremendously enjoyable and enlightening episode or webinar. Thank you, everyone, for attending. Special thanks, of course, to Vitalik for doing this grilling. And
Yeah, thank you very much, Vitalik.
Yeah, well, and thank you, Ellie, for like inventing half of this whole space. So, yeah.
Well, all credit on everything Cairo and Sierra goes to Leo, Shachar, and Oli. And many others, right? Sorry, here are. I think I get credit for not maybe putting too much. How do you say? Not blocking, unleashing it. Unleashing them on the world. Okay. Thank you very much, and see you. And go do StarkNet.
Yeah, perfect.
Bye.
Okay. Bye.